Hi, I'm Swarupa Sai, course instructor for Geotechnical Engineering 1. In this presentation, we will find out settlement from one-dimensional primary consolidation. There are three methods to calculate settlement from one-dimensional primary consolidation. First one is using E versus log of effective stress curve. Here we can see a plot of voids ratio E versus log of sigma V dash or log of sigma dash. This curve consists of two parts. First one is a recompression curve, second is virgin compression line, and third one is rebound curve. On virgin compression line, let us select 2 points corresponding to initial effective stress, that is sigma naught dash or sigma naught, and the final effective stress, that is sigma f dash or sigma f. Let the voids ratio corresponding to sigma naught be even and voids ratio corresponding to sigma f be E2. So even minus E2 will be delta E, that is change in voids ratio. By knowing change in voids ratio delta E and initial voids ratio E0 and the thickness of the soil sample H, we will be able to calculate consolidation settlement SC. So SC is equal to delta E whole divided by 1 plus E0 into H. Next method is using coefficient of volume compressibility. We know that MV is equal to change in voids ratio divided by V whole divided by delta sigma, which is the change in effective stress. But change in volume divided by original volume is equal to change in voids ratio, that is delta E, divided by 1 plus E0, which is original voids ratio or initial voids ratio. So we will replace delta V divided by V by delta E whole divided by 1 plus E0, and we get MV as equal to delta E divided by 1 plus E0 into delta sigma dash. But formula to find consolidation settlement SC is equal to H into delta E whole divided by 1 plus E0. We will write this equation in terms of MV. So we will replace delta E divided by 1 plus E0 by MV into delta sigma dash. So finally we get the equation for consolidation settlement SC is equal to MV into H into delta sigma. Third method is using compression and swelling indices. If the soil is normally consolidated clay, then current effective stress, that is sigma naught dash, is equal to pre-consolidation stress, that is sigma C dash, and it is also represented by sigma P dash. We have the formula to find consolidation settlement. SC is equal to delta E divided by 1 plus E0 into H. We will write this equation in terms of compression index, that is CC. CC is equal to change in voids ratio divided by log of final effective stress divided by original effective stress, that is initial effective stress. Here we have a plot of voids ratio versus log of effective stress, and we can see that the current effective stress sigma naught dash is equal to pre-consolidation stress, that is sigma P dash. Here there are 2 points being considered, and change in the voids ratio, that is delta E, is equal to E1 minus E2. And the corresponding stresses are sigma naught dash and sigma naught dash plus delta sigma dash. Delta sigma dash is the change in the effective stress. So initial stress is sigma naught dash and final stress is sigma naught dash plus delta sigma dash. And the slope of this line gives us compression index. So Cc is equal to y component, that is delta E, divided by log of sigma 2 dash, that is final effective stress, divided by sigma 1 dash, which is initial effective stress. Final effective stress sigma 2 dash is sigma naught dash plus delta sigma dash, and initial effective stress sigma 1 dash is sigma naught dash. We will write change in voice ratio in terms of Cc. So we get delta E is equal to Cc into log of final effective stress, that is sigma 2 dash, divided by initial effective stress, that is sigma 1 dash. And substitute the equation of delta E in the equation to find consolidation settlement SC. So we get SC is equal to CCH divided by 1 plus E naught into log of final effective stress divided by initial effective stress. And if the soil is over consolidated clay, then we have to consider two cases when the final effective stress is less than pre-consolidation stress, and for the second case we have final effective stress greater than pre-consolidation stress. Now we will check out which equation to be used to find consolidation settlement when final effective stress is less than pre-consolidation stress. Here we have a plot of voice ratio versus log of effective stress, and there are 2 points being considered on recompression curve. Delta E is the change in voice ratio for the points being considered. Sigma naught dash is the initial effective stress and final effective stress is sigma naught dash plus delta sigma dash. And slope of the line is nothing but swell index Cs. So we write swell index Cs as equal to delta E, or here it is delta E2 divided by log of final effective stress, that is sigma 3 dash divided by initial effective stress, that is sigma 4 dash. Your final effective stress sigma 3 dash is sigma naught dash plus delta sigma dash, and sigma 4 dash is sigma naught dash. And we will write delta E in terms of swell index Cs. So delta E is equal to Cs into log of final effective stress, that is sigma naught dash plus delta sigma dash, minus log of initial effective stress, that is log of sigma naught dash. And we will substitute the equation for delta E in the equation to find SC. So we get consolidation settlement SC as equal to Cs into H divided by 1 plus E naught into log of final effective stress divided by initial effective stress. And in the second case, when final effective stress is greater than pre-consolidation stress sigma C dash, we have the equation in terms of swell index and also in terms of compression index. Cs is the slope of the recompression curve and Cc is the slope of version compression line. So in the first part, the final effective stress is sigma C dash, that is pre-consolidation stress, and initial effective stress is sigma naught dash. And in the second part, wherein the equation is in terms of compression index Cc, the final effective stress is sigma naught dash plus delta sigma dash, and initial effective stress is sigma C dash. These steps will have to be followed to find consolidation settlement. First one is to calculate current effective stress, that is sigma naught dash, at the middle of the soil sample, that is clay layer. Later on, we need to determine pre-consolidation stress, that is sigma C dash, from the voice ratio versus log of effective stress plot, if the value of pre-consolidation stress is not given in the problem. Then we need to determine whether the clay is normally consolidated clay or over consolidated clay, and this can be done if we know over consolidation ratio. Later on, we need to find out delta sigma, that is change in effective stress. After that, we need to use following equation depending on the type of soil, that is if the soil is normally consolidated clay, the first formula to be used, and if the soil is over consolidated clay, we need to check out whether the final effective stress is less than pre-consolidation stress or if it is greater than pre-consolidation stress, and accordingly second and third formula has to be used to find out consolidation settlement. These are the references. Thank you.